So in this video, we are going to be solving the equation that you see on the screen right now. And to get this one started, first and foremost, after you realize you have a rational equation, you want to factor all denominators. I keep reminding everybody to factor all denominators. The only time that you're not factoring a denominator is either when it looks like this, right? X minus 9 or X minus 3. Or when maybe you have, say, just as an example on the side, a denominator, I'm just going to make the top one, like x or 1 over, and again, the top could be anything. So we could even make it, let's make it more interesting, x plus 1 over 6x squared. In these cases, there's nothing to factor, so you don't have to factor. And then when we have more or less 1x plus or minus a number in a denominator, and let's make the top x squared minus 3, whatever, that denominator you can't factor either. These are all more or less prime, or they're fully factored already. So that's prime, prime. Now we have a quadratic trinomial, we're going to factor it. So I'm just going to kind of jump into it. Any work you need to do on the side, you could do on the side. The a value is 1, so we could go right to x and x. We'll multiply to give us 27 and adds or subtracts to give us negative 12. Chances are, I mean, it's a rational equation. There's probably going to be some clues sprinkled throughout. So minus 9 minus 3, double check. Outer is minus 3x, inner is minus 9x. That makes the minus 12, and then negative 9, negative 3 makes plus 27. So we're in good shape. So hopefully you did the same up to there. And then you're going to multiply your entire equation, 1, 2, 3 parts of it, both sides, by the least common denominator. So what is the least common denominator? Well, 2 of our denominators have x minus 9 in them, so all 3 would want it. And 2 of our denominators have x minus 3, so that one would want it. So the least common denominator is x minus 9 times x minus 3. So if you were to ask, I don't know, Google or something, what's the least common denominator of blah, 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 blah. It might tell you that. I don't know if Google tells you that, but maybe. Or it might tell you this, which is the same thing, just expanded. Now, let's make sure, really, these are the critical steps, right? Factoring the denominator, identifying the least common denominator, and now the last, one of the most critical steps, especially because I don't have subtraction anywhere, when I distribute this, do I do it correctly? So one way to show, if I just grab this little slip of paper over here, I'm going to write down my common denominator, which was x minus 9 and x minus 3. That's this guy over here. And now it's going to distribute. So if it goes here to this first fraction, it's in the numerator with that x minus 5. I mean, I could lower this and stick it like right there, and we could just say they're all one happy family on the numerator. But what reduces the x minus 9, and what stays behind is the x minus 5 and the x minus 3. Now, if you're writing this, x minus 5 and then x minus 3 in parentheses, shame on you, you need parentheses around x minus 5 as well. All numerators and denominators have implied invisible parentheses. Plus, continue, now we take this least common denominator, we're going to multiply it by this guy over here. So they're all one happy family, but x minus 3 crosses out. So plus x plus 3 was there to begin with, and then x minus 9 stays with it, equals, and then lastly, it goes over here, and really both of them cross out because there's a match on top. So the only thing you should have on the right is negative 4x squared. I would say this is a spot where people sometimes mess up, because I think when everything crosses out, sometimes people feel like something has to stay and they end up writing both things and then they're getting something to the 4th power. So that could be an area where you make mistakes. So now from here, I'm going to expand, and I'll leave that there for now, but then I'll end up adding the 4x squared to this side and getting it equal to 0 because it'll be a polynomial for us to solve, right? Right. So if I expand this one, the FOIL method, x squared minus 3x minus 5x, the middle term should be minus 8x. Hopefully you have the same. And then last times last ends up to be plus 15. Plus, now here, x squared Minus 9 and plus 3 is minus 6x. Plus 3 and minus 9 multiplied to give me minus 27 equals negative 4x squared. So that's where we are now. Now, I guess I could kind of try to do two things at once here. So x squared, I have 2x squared. I'm also going to add 4x squared to both sides. So kind of doing this guy right over here. And that'll become 6x squared. Hopefully that doesn't get messed up. Then negative 8x and negative 6x. That's negative 14x. I could put it there or here. I don't know, either place. And then plus 15, but minus 27. So 15, 27, how far apart are they? So 5, 12, so negative 12 is 0. Minus 12 is 0. Okay, now it looks like a beautiful quadratic trinomial, AC method, but ew, these numbers, they're so terrifying. But what is the first factoring method we should always try? Greatest common factor. So all of the numbers are even. So let's take a 2 out and make our lives a little easier. Now we have a 3x squared minus a 7x minus 6. That's a little bit less intimidating now. So the GCF was 2. We took that out front. Now I could try a little bit more legit and more graspable AC method. So 3 times negative 6 and we get negative 18. 1 and 18, 2 and 9, 3 and 6. But I need these numbers to add or subtract to give me negative 7. So looks like these two would be pretty good. So that would be a positive 2 and negative 9. Now, I don't want to do the full-blown AC method with grouping. I'm going to do the cheap trick. So the 2 will stay right there. Let me push this up a little bit. I'm going to set up the double bubble. Now, 2 and 9, what do people want to write? X plus 2, x minus 9. That's wrong. Your first term will be wrong and your last term will be wrong. The only one that will be right would be your middle term. So that's no good. Your leading term is a 3, right? Or your leading coefficient is 3. You don't have a 1 there. When you have a 1x squared, you can just stick those in the parentheses with x's and you're good. So 3. Well, 3 is prime, so I know I need 3x and x. It's kind of easy. It's like a great scenario to ask for. And now 2 and negative 9 are really what your outer product and inner product are going to be. Since that's a 3, do I want the outer product to be 2x or negative 9x? Well, 2 doesn't come out of 3 easily, but 3 times 3 is 9. And we said we wanted negative 9, so that'll be a minus 3. And then this, I want to be a positive 2x, so I'm going to put plus 2. So inner is positive 2x, outer was negative 9x, and what did that give me over here? Negative 7x. So now we are factored, and then just finish it by a little solving. So 3x plus 2 equals 0. Oh, well, actually, for those of you who do 2 equals 0 or x equals 0 or something, it's really, you would set 2 equal to 0, but does it? Can it? No. So that's nothing. If it was 2x equals 0 or x, that makes more sense. But if you don't have a variable there, no go. Also remember, the biggest power is the maximum number of answers you would get. So if you end up getting 3 answers from this, something's wrong. 3x plus 2 equals 0, subtract 2, 3x equals negative 2. X equals, I'm very squished down here, negative 2 over 3. And then x minus 3 is 0, so x is 3. But of course, what did I not do? I did not write down my restrictions because I always forget. So looking back at the original, looking at the factors here, or what I sometimes think is easier is I look at the least common denominator I multiplied through by, and I just remind myself that these each can't be 0. So what are the restrictions that come out of that? X cannot be 9, x cannot be 3. So those are your restrictions. Those are our solutions, but wait a minute. X can't be 3, x is 3. X can't be 3, but x is 3. So we're going to draw a line through it. I'm going to draw an arrow. I'm going to label this bad boy extraneous. So that's your extraneous solution. So the only actual solution, final answer, solution, or solutions, depending on each problem, but x equals negative 2/3. Leave it a fraction. Fractions are our friend. Better than a decimal there. And there we have it. So we have an extraneous answer. We just mentioned that on the side. Final solution, restrictions, if we want to label that, might not be a bad idea. Circled anything important. Restrictions. And there we go. So hopefully you were able to get that right answer. Hopefully you did everything correctly leading up to there. So if you need another example, go into the corresponding playlist and hope you feel smart.